Let's see.
How does fractal and Mendelbrot stuff fit in? Have you given that thought? How that might have a relevance to all that?
Well, it's relevant in the sense that novelty theory is a wave mechanical view of nature that assumes that the basic pattern of cohesion and change is repeated at many, many scales. That's what a fractal is. It's a self-similar curve. You all understand this, right? It's simply it's a curve made of smaller versions of itself, and every level of the curve is made of versions of itself at different scales. The most obvious example to look at in your mind is a circle. Think of a circle. As you zero in on a portion of the circle, it has slight curvature. While as you zero in on a portion of it 1/100th the size of the first portion, it still has slight curvature. At all scales, the curve is self-similar. A circle is the simplest of all fractals. It's also the most boring. I mean, not for other reasons, but fractals, until the advent of computers, were very difficult to calculate. They were only called fractals since the 1970s. Before that, they were called pathological curves. And the reason they were called pathological was because it was hellaciously difficult to calculate them. Literally, it would make you lose your mind. I remember when I was a kid, I knew about these things, and I knew the method for making them. I mean, the method is very simple. Draw a shape on a piece of paper. It could be an L. Now replace, you know how an L is, oh, I drew it backward, but here's an L. Now replace the down swoop of the L and the horizontal swoop of the L. Replace each one with an L, and you get a thing which looks like this. You can follow that, right? Well, now replace each one of those straight segments with an L. Now you have reached what is called the second fractal stage of this particular figure. Now replace each of those straight segments with an L. But what you discover is by the time you get to stage 4, 5, or 6, by the drawing on a piece of paper method, the thing has become hellaciously complicated, and higher stages of the fractal can't be calculated at all. It has too many strokes in it, if you want to put it that way. But in a computer, this is the kind of stuff computers eat for breakfast, and you can produce fractals up to the 12th level of iteration. And what's strange is that when you do this, it's very hard to predict how the fractal is going to look. You know, you start out with something just like the L, with being replaced by L's. But by the time you get to the 8th or 9th level of iteration, the thing looks like exquisitely designed Louis Comfort Tiffany jewelry or something like that. It's very, very hard to predict. Well, this is how nature builds, apparently at every level. An example would be, you know, the veination on the surface of your liver and the delta of the Nile from an altitude of 200 miles do not look different at all. They obviously are built and created by the same forces which divide fluid dynamics into finer and finer flow. This is probably the most powerful insight into the mathematical structure of nature of the last 1,000 years, which is saying something when you consider that the calculus is a contender. But all of nature yields to this insight. You know, one of the things that they talk about, like the question, what is the length of the coastline of England? This seems like a fairly straightforward question until you actually begin to measure the coastline of England. And you discover that unless you make certain arbitrary assumptions, the coastline of England is infinite. You know, are we going to measure with a stiff measuring rod that is a mile long, or a foot long, or an inch long, or a millimeter long? The shorter our measuring stick, the longer the coast of England becomes. And the question, what is the length of the coast of England, is a meaningless question. Choose a number. That's your answer. You can always reason backward to assumptions that would give you that answer. Fractals are very real in that they are not only spatially happening, they are temporally happening. Before I go to temporal happenings, an example of spatial distribution of fractals is dust bunnies. You know, dust bunnies are those weird agglomerations of hair and crud that live under beds and in the backs of cupboards. Well, they come in all sizes. They come from too small to see up to occasionally Moby Dick-sized dust bunnies, where cleaning has not gone on with sufficient diligence. Also, the temporal processes are fractal. My most personal encounter with the power of fractals in nature, I've told this story, but I guess it doesn't hurt to tell it again. I was with a group of people in a workshop many years ago, and we were on a beach down north of Vandenberg, a very large beach. It's called Point Sol. I don't know if you can still get in there, but it's beautiful. There's all kinds of sea life and undisturbed beach. So I was on this beach, and I was walking, and I was in an altered state such that I was paying very close attention to what was going on around me. And after walking for a while on this absolutely white beach, I came upon a little black rock, just a flat rock about that big. And I noticed it, because there was very little to notice on this beach, and I was sort of shelling in a half-hearted way at the time. So I noticed this black rock, and then I kept walking. And I came after quite a while, after 5 minutes of walking or so, I came to an identical black rock, just like the first one. And I thought, well, that's interesting, strange. And then I had, as you sometimes do in altered states, I had an idea which burst on me, fully formed. I stopped walking along the beach, stopped at the second black rock, turned around, and I walked back to the first black rock, and I counted my steps. It was like 720 steps. And then I kept walking south on the beach, and I began the count again from 0. And at 723 steps, there was a third black rock lying on the beach. Well, rather than yield to the idea that the aliens were directing me, or that this was a revelation of God's intent for man, I realized, no, it's nothing like that. What it is this enormous bay and this perfect beach are actually functioning as a computational engine of some sort, solving a fractal equation, a dynamic equation that dictates the placement of black rocks on this beach. And I'm sure had I walked south another 720 to 30 feet, there would have been yet another black rock. Well, unless you're loaded, this kind of thing will completely escape you 99.9% of the time. But that doesn't mean it's not going on. It is going on. You know, we think of computers as artificial things under the control of human operators and so forth. But in fact, all nature computes. All nature computes. I remember once being, again, strangely enough, you have to sort of slow down and observe with psychedelics or you miss these things. But I discovered something almost anybody can observe if they will but take the time. And that is, after a rain, if you go into a place where there are dense bushes or leaves, and that every drop of water that comes down at the end of a leaf, like on the point of a maple leaf, if there's a flat surface behind that drop of water, and you position yourself very carefully, the light passing through the drop of water will create a fisheye lens image of the entire scene around you. No eyes are involved, no animals are involved. This is just simply a drop of water in the presence of light creates a 360-degree fisheye lens image of the world around it. Until I saw that, I couldn't understand how in the world animal eyes ever evolved, because you imagine that it's mechanically complicated. You know, so how can an animal see something? It must involve very complicated mechanisms in chemistry. No, just hang a drop of water at the end of a toothpick and position a piece of typing paper behind it, and then carefully search for the right perspective, and eventually this little image of the world emerges. It's almost as though the world wants to warp itself into a total image of itself. It has within itself this capacity to image itself 100%. That was the answer to the question about fractals. It sidetracked me from the other thing I wanted to mention. Not that that's a bad thing. But the other thing I did want to mention was, and this isn't an argument for the truth of novelty theory per se, it's an argument for the fact that things are more novel than we suspect, and that novelty can come from unexpected directions. And that is this data that came out, I believe it was last September, where this fellow Anton Zellinger and his group in Vienna at the Quantum Center for Quantum Encryption teleported a photon a distance of about 15 feet in a laboratory. Well, now this is a technology which I would have, if you'd offered me a bet, I would have said is impossible on any scale, 10 years, 1,000 years. I mean, this is a really counterintuitive technology. The photon was destroyed at its origin point. It did not travel between the 2 points. It was destroyed at point A, and it instantly appeared at point B. Instantly, notice, not at the speed of light, but instantly. And the mathematics which allowed this to be done place no upper limit on the structures which will behave this way. In other words, it was done with a photon, because a photon is very light, very easy to move around. You don't have to pump much energy into a photon to get it to do what you want. But the experiment did not preclude doing it with an electron, or a molecule, or 10 high 16 molecules for that matter. In other words, this seemed to be a technology where it's Star Trek stuff. You know, you step onto a platform, every atom in your body is ripped asunder, and you instantly appear thousands, tens of thousands, perhaps hundreds of thousands of miles from where you started. And you have not made the trip. Your new body has been assembled instantaneously out of locally available matter at the arrival point. And the people who were doing these experiments said they felt that scaling up this technology and doing it with, macrophysical objects was 5 to 6 years away. This is one of these things where I assume they'll hit speed bumps along the way. But imagine the impact of a technology like that on our image of ourselves. I mean, imagine if several times a day your body was blown completely to smithereens and reassembled out of the air you breathe some hundreds or thousands of miles away from where you are. Just what this would do to our notion of ourselves. And of course it impinges on questions like, is there a soul? And if there is, can it withstand that process? And if so, how? In Islamic teachings, they say the human soul can move no faster than a horse's gallop. This is why, this is an explanation for jet lag. You fly to Paris, your soul is moving along at about 35 miles an hour. It takes it several days to catch up with the transported body, and then you sort of feel reunited with yourself and whole again. Let's see if I can think of anything else along those lines. That was pretty startling stuff. The real technologies which shape the world are somewhat unexpected, I think. Like, for instance, if you read future fantasizing of the year 1800, there is no hint. It's a mechanical fantasy. There is no hint that within 50 years telegraph lines will be strung, and that within 100 years radio and telephones and moving pictures. All of that comes basically out of the occult discoveries of the 19th century, that there were such things as electromagnetic fields, that these electromagnetic fields were not mere objects of theory, but that, they could carry symphonic music and human speech and pictures around like that. An electromagnetic intrusion from well, these things are unruly.